Hello, welcome to another episode of my series about the Rust programming language. So now we're up to looking at loops. We're going to look at three types of loops today. The loop, while and for commands. So I've already created a container in Cargo and called it loops, and I've already copied in my code here, so we're ready to go. Now, one thing I did want to bring to everybody's attention, I've mentioned in previous episodes I'm using the physical copy of the Rust programming language. This is a good example in here where there's some additional teachings, if you like, which I'll talk about as well. So let's just go back to the code and we'll work our way through some of the examples here and just explain the ins and outs of loop, while and for. So the loop is the simplest example here, and if this break command wasn't here, what would simply happen is that this loop would go on running indefinitely until over in here, if we're running it from the command line, when we run the program, we did Control-C. I'm not going to attempt that because there's a danger that when I use Control-C I might get bounced out of my screen capture software. So yeah, being a bit cautious about doing those sort of things. But if you want to see it, you can test this yourselves and you'll see exactly what happens if you try and do a loop with something like this in it, and it'll just keep looping round and round, printing again and again. So with the break in here, if we just do cargo run, and because we're in the loops folder with our, let's just save that. And if you've jumped in at this episode and this makes no sense, then please find the starting episodes and watch from there, because it will make a hell of a lot more sense. So you can see, obviously this is code later down here, but there we're just getting a single again. So what's happening is it's going through the loop, but because of the presence of a break statement, it breaks out of the loop. Now obviously there's going to be much more complicated loop statements than this that you'll want to utilize, but it illustrates a really important point, is that, you know, obviously the positioning of the break command is really important, because what happens is it will loop, and then normally what you would see is this break command would be triggered by some sort of condition being met. There wouldn't just be a straight break in there, and so there would be a condition being met that would be tested for. If that condition was met, then it would break. Now you can move that position within your code block that's inside of the loop, obviously to behave in certain ways and to execute a certain amount of code before the break could potentially occur. Now, one interesting thing I did notice, and this is another cool feature in here, not that this probably would ever happen, but if you got to a situation where the break command was before any of your code block, and Rust from that had inferred that you'd create a situation where the code would never run, so you had redundant, you'll get this sort of error about unreachable statements. So yeah, again, Rust being super helpful, but this is a fairly basic example that would probably never happen, but just good to see, you know, the sort of general principle behind things. Now I'm just going to switch back to the online stuff, because I wanted to dig a little bit deeper here. So I mentioned about, obviously normally you would find break commands within the context of some sort of check, some sort of conditional check. And you can see it here. We've got various commands here, and you can see there's also loops inside of loops. Now that's important because when you've got loops inside of loops, you need to know where you're going to break to. Now the default in loops is when you issue, say, break commands or continue commands, it applies to the innermost loop, at whatever the innermost loop is at that point where the break is. However, it is possible, and this isn't mentioned in this chapter of the physical book, it is possible to use these loop labels to force it, when the break occurs, to break out into a loop that's not the innermost loop. So just so you're aware of it. So that creates, depending on how you look at it, might be good, might be bad, but that creates some interesting situations, or you can create some interesting code which doesn't follow the sort of default way in which a break will behave inside of a loop. And you can see here there's two nested loops, one of which counts up, one of which counts down, and by sort of careful placement of regular breaks, which just break out to loops, and breaks which break out to a loop label, you can see here there's one called counting up, you can create some interesting loop interactions. Now of course there could be better ways in Rust of doing that, but this is just a good illustration of how breaking and loop labels can be used together to override, if you like, the default way in which breaks and loops behave without label loops. So yeah, placement, super important, both within the loop itself and where loops are inside of loops. You can also return values from a loop in the same way that you can return values from an if statement and use them in combination with a let statement. So here we've set up a mutable value using mut in combination with let. So counter is mutable. So if you remember, immutable means you can't change the variable. Mutable means you can. And by default in Rust, variables are immutable. So we have to put in this mut command in order to override the default behavior. So we're setting that to 0, and we've made it mutable because we want to increment it by 1. And here we're using a loop to loop over that incrementation, but also we're using a condition to break out. Also here, at the point in which we break, we're multiplying that counter by 2. So that also illustrates that you can in fact execute additional code after the break and before the sort of end of line, end of command, end of this particular piece of code. And again, you can experiment with more complicated versions of this as well. You know, whether there's something that you want to execute at the point at which it breaks. So what this one here will in fact do is it's going to be counting through, and then it's going to return the value back and set that value in this let command to the variable result. So bind it to result. Notice this is immutable because there's no mute or mut command there to make it mutable. So by default it's immutable. And so the result is going to be 20 because it counted up to 10. Once it got to 10 it broke out, and at the point it broke it was multiplied by 2, which makes it 20, and then assigned to result. Now a lot of what we've seen already, you'll probably realize that there's better ways of doing this than using loop commands, or better ways of doing things. One useful alternative to loop is while. So this is where you want to be doing something while a condition is met. So for this one, all the while number, the variable number, is not equal to 0. Do this particular loop. You can see here's the while statement, here's the end of the loop. So we've previously set this to 3. We've made it mutable because the number is going to be changing inside of this while loop. And you can see it's being decremented by 1 each time. Notice the neat way that's done in Rust. I'm sure anybody that's coded in C and all the different spin-offs from that will be familiar with this way of decreasing a variable by 1 rather than doing number equals number minus 1. And as it's going through, another thing it's doing is that all the time this is being executed, so all the time this condition is being met, all the while it's being met, it's printing out whatever's contained in this variable. So first pass through, 3, 2, 1, and then when it finishes, it goes down to this piece of code here, which just prints liftoff. Obviously, if the condition was met straight, if the condition was not met, so while the number doesn't equal 0, it's going to do it. But if that turns out to be false, then it's not going to execute. So if that happens straight away, it's not going to execute any of this code at all. And that's quite important in any form of language where you start to learn loops. You start to learn ones where that condition is checked effectively at the top, and if, depending on the result of that condition, you could get a result where the block code is not executed at all. And you'll see in other commands you've got like while loops, or you've got things that do things like do until, which will do things until a certain criteria is met, and you can use loops in various ways and while statements to give you the difference between a situation where a block of code might be executed a number of times before the criteria or the check is reaches a certain state, this here, or where they might execute it at least once and the check occurs at the bottom of the code. And I'm talking about languages generally here. And as we walk through this book, I'm sure we'll come across code examples where you would want the code to execute, or the block of code to execute at least once. And what is the best loop statement to do that versus the other loop statements. But with this, if we do this, you can see we just get liftoff straight away, because straight away it's 0, and while the number doesn't equal 0, do the while loop. So it equals 0, so it doesn't do the loop. Now, while can be used to loop over elements in a collection such as an array. However, there are risks when you set the index bound separately in a value, like you would have to do here. So what do I mean by that? Well, we've got our let statement, which is creating our array, and we spoke about arrays in a previous episode. So simple array, 5 values, 10, 20, 30, 40, 50, and it's creating here this a array. And if you remember in a previous episode, to access those, we're going to use an index. And you can see here the print ln command is going to print out whatever element in the array is accessed through its index. And if you remember, the index starts off with 0. So 0 is the first element in the array, 1 is the second, 2 is the third, and so on. So to do that accessing sequentially through the array, we're going to need an index that we can use to do that. And what we're doing here is, so all the while the index is less than 5, so it doesn't go out of bounds, it's going to keep going through this and printing out, and it's going to add 1 to the index. The index starts out at 0, so first time we go through we get the first element in the index, then we go through we get the second, then the third, the fourth, then the fifth. Once it goes, now again it's starting off at 0, so it'll go 0, 1, 2, 3, 4. Once it gets to 5 it breaks. So 0, 1, 2, 3, 4. Now there is a problem with this in that it's really easy to make mistakes. You could accidentally put a value in here which makes this go out of bounds. Supposing you put 6 in here instead of 5. You've only got, so that there's no connection between the number of values in here and the number you put here. So it's possible by changes you make here or here and you forget to do it in the other place, or a change you make here, to cause an index value that goes out of bounds. So let's just see what might happen. Now, anybody that's worked in other languages will know you can get some seriously out of whack results if you try something like this. It'll start pulling out of memory, like, values that happen to be in the next memory address, wherever the array is stored, those sort of things. But before we do this, the other thing to bear in mind, the conditional check itself also adds program runtime, making it less concise than it could be. So let's try a couple of things here. Let's take that up to 6. Yeah, index out of bounds. The len is 5, but the index is 5. You think, well, isn't that right? No, because it's not, because the index is 4 because it runs from 0 to 4. So there's 5 elements, but the elements run from 0 to 4 in terms of the index. And if you try and access above it, then you get this, which is nice that you do get an error. What happens if we were to do... Well, if we make a mistake here, like, for instance, 1, we're not going to get an error. As such, but it will start from that element. So Rust won't create an error, but it's not what we were trying to achieve. Let's try this. And again, I encourage people to do this. It takes a bit longer, and of course that's why these videos are so long. I like to, in a controlled environment, break something. So again, we're getting a slightly different error here. And that's because this was defined by default, it assumes that we're going to be using an unsigned variable, and we've used a signed variable. So, you know, it hasn't got to the point where it's trying to access the index because there is another problem there. So yeah, as you've probably guessed from previous episodes, I'm loving this checker that's built into Rust. Super cool. Okay. Let's put that back to how it was. Just in case ever you have to use the code again and then I'm not going, what's going on? You can see below it, I've given an example of a possible safer method for doing this, which is to use for. So if you use for, it's going to let you loop over for the elements in B. So what I've done here is I've got my array B, which I've defined here with 5 elements in here. So I've got the array with 5 elements, and I'm, for each element in that array, I'm going through them one at a time. So it's you know, knows how many times it has to go through the for loop based on the amount of elements in the array. I don't have to tell it, so there's no chance that I can be giving it wrong index values. It just works here. Now I wanted to look at the example in the code. No, that is the same. It might be in the book. I noticed in the book and the code, the code in the book and the code that's given here is slightly different. The way they construct the for condition here. They use, I think, an additional statement, but we'll go by what's on the website for this example. So much safer. Yeah, nice and safe, nice and concise. So here it's also got, even in situations where you want to run some code a certain number of times, as in the countdown example that used a while loop, most Rust stations would use a for loop. The way to do that would be to use a range provided by the standard library, which generates all the numbers in sequence starting from one number and ending before the other number. So that's where you're like counting through, and you do want like a value. I suppose this example where you're just using it to work your way through the elements. Now, an example where you're going to be counting through and you want the number is this one. So this is that lift-off code written as a for loop. So the lift-off code before, we used a while loop, but using a range, this is how a range looks in loops. We can do this, so we can say for num in the range 1 to 4 reverse, because we're counting down, so we're using this .rev to do that. This .rev here on this range. If we were counting to 1 from 1 to 4, we wouldn't need it, but we're counting from 4 to 1. And it will literally just go through this. Now, one thing you should notice here, again, be careful with ranges. So I'm going to run this again. Let me just make sure it's saved. And it's the last one we're looking at here. So you can see another area where you have to be a little mindful. We've come across this before. So this is an example where the first value in a range is an inclusive value, and the last value in the range is an exclusive value. So what it's doing here is 1 to 4, but it's counting through, it's going through from 1 to 3. And just to show you that, if I do that, so if you did want it to count through 1 to 4, and we saw that in I think previous example in that guessing game example where we were using a similar sort of thing. There was some ranges I think used there, and in the example that I had, I pointed out that again, just be aware, you know, this applies in lots of different places as to when you're using some sort of counting or working through elements, you understand what the boundaries are, what the bounds of that are, whether the values for the ranges are inclusive or exclusive or different at one end than the other, and so on. But yeah, that's a much more efficient way of doing this. Basically, again, you can see the lift-off bit is outside this block of code. So hopefully that's been helpful, giving you a bit more of an understanding of the different ways you can loop through things in Rust. I don't think there's anything I wanted to add any more from this. I am now tending to switch between, or checking between, the code in the book and the code online and see if there's ways in which I can highlight potential differences. But when you look at all of these different ways of doing this, you know, you're looking at, I suppose, mainly two things that are going to affect your choice. One is, what's the most efficient way of doing it in terms of, just execution of code? And secondly, what way is going to cause the least amount of potential bugs, or the probability for bugs, reducing that probability. And that's true of any programming language where you have a number of different ways where you can do the same thing. So yeah, that's loops. And then in the next episode, I'm going to be taking a look at functions. So thanks once again for watching. Bye for now, and I'll catch you in the next episode.